Welcome to The Explainer. Today, we're going to talk about a new kind of AI that's learning to be not just more powerful, but, a whole lot smarter about when to use that power.
So let me just start with a question for you. What if our most advanced AIs are kind of like using a supercomputer to calculate a 20% tip? I mean, sure, it gets the job done, but is it really the smartest way to go about it? Turns out this might be a much bigger deal than you'd think.
And this gets right to the heart of a real challenge facing AI development today, this problem of always-on thinking. You see, our most powerful models, they're built to reason, to think step by step through every single problem they see. And here's how that plays out. For a super simple question like, hey, what's this dish? All the AI needs to do is give a direct answer. But what's happening now is that these models often fire up this complex step-by-step thinking process that's really designed for, solving tough logic puzzles. They're using the same heavy machinery for every single task, no matter how big or small. And look, this kind of deep thinking is absolutely fantastic when you need it. But for the easy stuff, it's just incredibly wasteful. It's a massive drain on computational resources, which, let's be honest, translates directly into more time, more energy, and more money for every simple question it answers.
So, faced with this problem, a team of researchers at Tencent's Hunyan Lab asked a really brilliant question. What if they could teach an AI to have two different ways of thinking? Like a fast mode for the easy things and a slow, deep thinking mode for the really hard stuff.
Their solution kicks off with this clever training process they call bi-mode annealing. But forget the fancy name for a second. The goal is actually pretty simple. Teach one single AI to be fluent in two completely different styles. One is that detailed, step-by-step thinking mode, and the other is a quick, get-right-to-the-point, direct mode. So how'd they do it? Well, it was a two-step process. First, they put together this massive data set. We're talking over 16 million examples, and they carefully sorted them into questions that need deep reasoning and questions that don't. Then they just trained their AI on all of this mixed data until it was a master of both ways of responding. And to make sure this whole thing wasn't just a one-trick pony, the training data they used was incredibly diverse. I mean, it covered a huge range of topics, everything from math and charts to just general knowledge, to make sure the AI's new dual-mode ability was genuinely versatile. But, of course, there was a catch. After all this brilliant training, even after mastering both modes, the model picked up a very human-like bad habit. The researchers actually called it thinking atrophy. And what does that mean? Well, basically, the AI got lazy. It figured out that quick, simple answers were usually good enough, so it started defaulting to that mode, even for complex questions where it absolutely should have been thinking deeply. Okay, so this was the real make-or-break moment. The AI had the two skills, sure, but it completely lacked the judgment to know which one to use and when. It had to learn when to think. And their solution for this was a really clever reward system they call bi-mode policy optimization. Using a method called reinforcement learning, they basically taught the AI to make better decisions by giving it a reward every single time it chose the right thinking mode for the job. So here's how that actually works. For any given problem, the AI has to generate two different answers, one using its deep thinking and one without. Then it gets a reward. Think of it like a little digital doggy treat, but only when it correctly chooses to use its thinking mode on the tough problems. Now get this, because this is the really wild part. They only used math problems to train this reward system, but somehow, by learning to be smart about just that one subject, the AI generalized that lesson. It became what they call an auto-thinking model, able to make smart choices across totally different topics it had never been rewarded for. All right, so that's the theory. But the million-dollar question is, did it actually work? Did this new, smarter model, which they called R-4B RL, really perform any better out in the wild? The results were, pretty staggering. On a bunch of really tough reasoning benchmarks, this new 4 billion parameter model just blew a model 4 times its size out of the water. Now, you can think of parameters like the number of connections in a brain. Usually more means more power. But here, the smaller, more efficient AI won. It wasn't just stronger, it was smarter. But raw performance, that's really only half the story. The real game changer here, the thing that gets me really excited, is the efficiency. And this chart says it all. The efficiency gains are just dramatic. On simple tasks, the new auto-thinking model is incredibly lean, using just a tiny fraction of the computational power, or tokens, compared to the always thinking one. It knows how to save its energy for when it really counts.
So what you're really seeing here is the holy grail. It found the perfect balance. It maximized its performance on the hard stuff while minimizing all that computational waste on the easy stuff. This is truly top-tier performance at a fraction of the cost. So let's bring this all home. What's the big takeaway here? Why does an AI that's efficient and not just powerful matter so much for our future? Well, it really boils down to three huge things for all of us. First, accessibility. Smarter AIs can run on the hardware we already have, like our phones. Second, cost. It makes running these gigantic models way cheaper and more scalable. And finally, sustainability. This is just a greener, more energy-efficient way forward for building the future of AI. So I'll leave you with this final thought to chew on. Maybe, just maybe, the next great leap in artificial intelligence isn't going to come from building bigger and bigger models, but from finally teaching them the wisdom to know when and how to think.